friend of mine just invites me on a regular basis to perform lectures.
Are you on a regular basis say no, thank you?
No, on a regular basis, yes. Yeah. And then, but he always puts it into uses both keys. He's quite creative on writing acronyms.
Oh, right.
And today it's Augsburg, it's German Karl, yeah. And it's Augsburg versus Dortmund. And he wrote Puppenkiste versus Beanstalk. Whatever. So, you know Augsburg or Puppenkiste? You know that?
I have heard. So he's got names for everybody, every team in the top two divisions of the.
But they changed from male to male.
Oh, right.
The next time it would be different. But yeah.
This man clearly has a lot of time on his hands. So yeah, just a tiny bit of setup, and then we'll take a look. About 50 minutes or so, and we'll see where we get to. So we've downloaded a few files. It's just some data files and a few Python scripts just to give us something to work with. So we've got a directory called books, a script called word count, and a script called plot count, which is what you should have when you have finished. So make is, as you probably are aware, is one of a number of build automation systems. It's been around for a long time, 1976 or 1977, I think, originally developed in the United States. It's lasted an awful long time, despite the fact that other tools have been developed, have come and gone in the past, because although it can be quite difficult to use, it's really robust, and it's almost guaranteed to work on any Unix-based platform, and increasingly on Windows platforms as well. Traditionally, we've used Make with compiled languages like C and Fortran to do all of the compilation and linking to libraries for specific platforms, but we can use it for a whole lot more, and that's when it begins to get really interesting. You've probably used Make in conjunction with what we term the GNU Auto tools. So it's the family of doing a configure, a make, and then a make install. So that's usually the three things we do when we're installing new software. So the configure script building is something that creates the file and make uses, the thing called make file, in order to perform software installation. And we often use this when we're installing somebody else's software for a particular target platform. We probably won't get as far as that in the next 15 minutes, but let's just do some basics. We'll look at the structure of some make files, and then we'll see how we progress. Right, okay, so in that directory, as I said, you should have a directory called books, one called plotcount.py, wordcount.py, if you have extracted that data properly. So let's take a quick look at word counts. So this is a not very interesting program that reads in a text file, counts the number of words, and outputs a data file. So a fairly typical data processing application. So if we were to do Python wordcount.py, I know in the books directory there's a text file called iles.txt, and we're going to produce an output file iles.dat. Okay? So we're going to assume it's produced some output, which it has. There it is, iles.dat. And if you take a quick look at it, we've got some data about the words in the original text files. We've got the word itself, We've got the number of times it occurs, so the appears 3,822 times, and that's 6% of the total word count in the document. Of, depending on your pronunciation, 2,460, and etc., etc. So we get a decreasing number of terms in the document. So that's fairly straightforward, I think. So let's do another example. So let's do Python word counts. Oops.py. I know there's another book. It's TXT. And we'll call that one this. Okay, so we do some more data processing, and we'll take a quick look at that one. Okay, same sort of thing again. Oh, no, not this, not that. There we go. Now, I don't know about you, but that, I think, is a very boring way to process data. Okay, so we've done some pre-processing. Let's say we want to do some basic visualization. So there's another little script there, plot counts. And what that does is takes that data and creates a JPEG. Now, I'm hoping this doesn't rely on a library that I forgot to install or overwrote. Probably did. What have I got there? May or may not have done. Yours may or may not work. Did that right? No, it didn't. So I probably not installed the library I need for this. Did yours work? Did your JPEG
Mine.
Who did?
Mine's not working.
Mine.
Somebody did, but that's on your laptop. The first part of the pipeline works anyway. But what we can see is a fairly standard data processing pipeline where you read in a data file, you do some sort of analysis, you generate an output file, you point another script to your output file, and it generates some sort of visualization. That's the process that we've gone through there is great if we only do one or two data files. If we've got 20 or 30,000, which would not be uncommon in a large project, then we're very quickly going to be bored. We're very quickly going to need to employ a master student to do all of this typing for us. But we can save ourselves the money, spend the master student salary on beer, and use make and a make file to automate this process. So that's the plan. So as I said, normally you're probably used to using make to install, but it can be used for any automation process. And that's what we're going to have a look at today. Because of course we're focused mainly on Python, and Python, as we know, is an interpretive language, so that whole building and compilation stuff is a little bit less interesting to us. As I said, there are tools newer than make, but every system has make available. Okay? And because it's text file based, because it doesn't require any complex GUIs, because we don't have to write JSON or XML, which are not very human friendly, it's a very accessible system to put a little bit of effort into learning how it works in the first place. So, there we go. So what we're going to do is use or create a file that drives the make program. And that's something called a make file. So what I'm going to do is create a make file. And make files, a default make file, is called makefile with a capital M. We can call it anything else. Right? But when we type in make looks for a text file called makefile. So it's sensible to call it makefile. Capital M is important. Okay, so that differentiates from anything else.
Why is that capital M?
It's the history of make.
But does it really only look for capital M?
Yeah, capital M makefile. Yeah. if you call it anything else, so for example, people tend to, when they distribute software, if they know a little bit about the types of target system that people are likely to install the software on, they will give you a number of makefiles pre-built. But they might be called makefile.lsx, makefile.x86, makefile.x86_64, or something like that. If you want to use a specific makefile, then you have to give its name after the make command, or rename it to makefile. That's how the system works. So what we're going to do is get it to be part of this automation process. So any section in a makefile, we can use comments much like we would use in a bash script or a Python program. So we're going to do that count words. So I'll just type this in, let you do the same, and then we'll talk about what each of the individual bits mean. Just what we did before. So in general terms we call this a build file, but as far as make's concerned it's called a make file. So let's look through the various sections. So right up at the top, count words is a comment. Yeah, we recognise that as a comment from elsewhere. Isles.dat is what we call a target. So that's something that's going to be created as a consequence of the action that follows. We need to have targets. Targets often have dependencies. So the bit that comes to the right-hand side of the column, books isles.txt, is a dependency. And a dependency is a file, or a number of files, that's needed to build a target. Yeah? So in order to create isles.dat, I need books isles.txt, the target dependency. The colon is the separator between targets and dependencies.
Spaces, two spaces between the columns. Or
So it isn't critical to put a space in. I do for readability. Yeah.
and for the column.
For which one, sorry?
After isle.
After isles.dat. Oh, between the spaces there are not critical.
Okay.
But put it in for readability.
Okay, but the spaces in front of Python there are
So tab.
Tab.
Sorry, yeah. So that's a tab character, I should mention that. So you indent via a tab in a makefile. Yeah. Not 8 spaces. I should have made that bit clearer, sorry. That's an action. So we've got a comment, we've got a target, which is the thing that's going to be built. We've got the dependency, which is what is needed, and we've got the action that's going to build the target. And that, altogether, is what we call a rule. So rule consists of, if you do it properly, a comment, because we should all write self-documenting code. Got to have a target. It doesn't necessarily have to have a dependency. That's not critical. There are some targets that don't have dependencies. But you've almost certainly got to have some sort of action, or otherwise it ain't going to know what to do. Yeah? So let's save that. There's my makefile. So I don't want my dats. I'm going to get rid of my dats, and I'm going to get rid of anything else I don't like the look of. So otherwise, I don't know whether it's worked. Do I? I leave the dats in place and might not trust people. So let's remove the dats. when you run make, it looks for a make file and performs the actions based on the rules that you've given. So what we should need to do, try it, is type make, hit enter, and see what happens. And what make does is it prints out the action. So what should have happened is that it's created the target. There it is, R.dat. So we've created our very first make file. So make files are a very simple way of automating the process. As I said, you don't have to call a make file a make file. So let's try rm, start with that again. And if I change the name of the make file to, I don't know, makefile.something, let's call it that. I try and run make. It tells me, don't be stupid, no target specified and no make file found. So I can specify the exact make file I want to use. And that's by using these, the -f for file name flag, like so. So if you want to give people an option to use different make files, then they should know to use the -f operator, the -f flag, to choose the correct make file to use. I'll rename that back again, so got something that works. Let's just try running make again and see what happens. I've already got isles.dat. So when make runs, it checks the last update date of your targets. And if that matches what it thinks it's just made, then it won't build it again.
How does that work? I mean, I do use it for compiling, and it checks if I changed the source file of the code.
Yeah, in which case, if you haven't changed, it won't rebuild.
Right,
if you have
so
changed,
it checks I've never quite got that. So what is checked? I mean,
let's have a look at what it checks.
Okay.
Yeah. Okay. So let's have a quick. I'll just get rid of a couple of files out of here so we can see it's a bit clearer. No, I'll leave that. So if you take a look at the timestamp of the file that we just created, so it's isles.dat and the books directory. You see the books directory was created some time ago, isles.dat was created today. So it looks at timestamps. Let's take a look in a bit more detail at the two files. So, that's the input file. That's the output file. That's actually it. So they're the two files that it it needs or it creates. So we've got a timestamp of 15th of November and a timestamp of the 16th of December from the thing that creates it. So, your source file, in your terminology, would be the Isles.txt file, wouldn't it? So if you change that, so let's change it. We're not going to edit it, but we can touch it to change the file that you were talking about. So if we do this, so if it's unchanged, let's do it again, sorry, try and get it right. So if I run make, it says Isles.dat is up to date, because the source file, books Isles.txt, hasn't changed. So what you want to be able to do is to change that source file. So let's do that by touching it. Like so. And you'll see that's been updated. So what we would hope happens now is that when we run make again, it rebuilds the destination, the target file, which should happen. So let's see whether that does happen, which it does. So it recognises you've changed your source file, so you've added more data to it, or you've added some additional code, but then and only then will it rebuild. Is that what you...
Yeah, so and actually it goes one step further, because usually if you have like Fortran code, you have dependencies of routines on other routines. So actually I have like a list of dependencies, and then I often encounter problems where make does not correctly, or it doesn't recognize that I've changed as a routine. That
in one of the dependencies?
Yes.
Right. Okay.
And then it won't compile the depending routine again, and everything goes.
Yeah.
Yeah.
It depends how many levels of dependency you list in your rules.
Okay.
So we'll see if we get that far. So depending on when those files were updated depends on whether they get rebuilt, and it also depends on whether they're listed as dependencies.
Yeah. Okay.
Yeah.
Okay. Okay.
So let's just go back to the main file. So no, we're going to add another rule. So this is just basic stuff really. So we've got there's our first simple rule. So let's add a second rule this time, where we've got it was abyss, wasn't it? So abyss dot that. So we're going to build abyss, and we're going to base it on abyss.txt. We're going to do the same thing again. So it's Python.py books abyss.txt abyss.dat. So remember, we've already run makefile. So we already run make on our original makefile, and it should have created an up-to-date version of Isles.dat. That should exist. So what should happen when we run make now with this new additional rule added? What will we see?
It's not going to make Isles pointed, but it's going to make added pointed.
It should, shouldn't it? Yeah. So we should only build the second rule, because when it checks the timestamps for the first rule, it can see that Isles.dat is built to the current Isles.txt. So it checks those two. It knows it's got the last built version already, so it skips that route. We'll give you a little message to say so, but it will build abyss.dat. So we'll make again. So make Isles.dat is up to date. Oh, hang on.
Same happened to me, and that was the normal as well.
And it happened to me as well.
So what's happened?
It wasn't built as.
Yeah, it's not built. Yes. That's unfortunate.
hasn't even given
So
you any
the way that make works is that the first rule in the list is what's called the default rule. Yeah? And if that one is met, it doesn't do the rest.
Okay.
It's late.
We can force it to do so. And to force it to do so, we can tell it which rule to run. Yeah? So the rule name is essentially the left-hand column, to the left-hand side of the column. So we can run a this.dat. So we can force it to run a specific rule within the make file.
That is what we see as make this clean, make clean, all
Yeah.
that stuff.
That's exactly it. So when you run make, it looks at your make file, yeah, and it will run that default rule. There are other rules in more complex make files, and make clean and make this clean are the standard rules for compiled languages to clean up all the crap of the build events that invariably get put there when we've not written a correct make file and it makes a broken version of our code. So we can go, oh, bugger, make clean, make this clean, and try again. That's what we do, isn't it? So they are rules further down the list. So we're forcing specific rules to run that don't run by default. Those two, particularly, we would not want to run automatically because they are two rules that we reserve, two keywords we reserve for particular types of events. Yeah, so they have to be kept away from the default rule at the top. Well, yes, you're quite right. So, why not? Let's do that actually. Let's make a clean. So we've added a clean rule.
Couldn't we like put a dependency there that those files should exist at least?
What will happen with an rm minus r, with an rm minus f if the files don't exist?
It's fine.
It's fine, isn't it?
Why you put the minus f?
So it doesn't, we don't need a dependency if we use minus f. So what we're trying to do is think about a way of making the rules as simple as possible.
Okay.
Yeah. And that makes it as simple as possible. If there's one thing you can almost be guaranteed, is that users are idiots. Yeah? So if you are looking for a particular dependency that people manually delete files, that is then not met by your rule, your make clean isn't going to work. Yeah, so you're keeping it as simple as possible. And then to run that particular rule, it's make clean. Well, let's just check I'm not lying to begin with. So there are some two dats there. Let's just do make clean. And my dat files are disappeared. Yeah, so we've got targets, dependencies, rules, comments, default rules, running non-default rules. Yeah? Good. Now I need those very much. So there isn't something built called clean. So although that's build events, there isn't actually a target generator called clean. So there's a create file called clean, whereas the previous rules did create files called something.dat. It's a shorthand. Yeah? However, that in itself can cause us some problems. Let's see what happens. Let's go back. So let's do. Let's make files.dat and. So I'm running those two rules, the create those two files. Yeah? But let's try and see what happens if we've got something that exists in that directory called clean. Remember, it's a rule. It's trying to build something, isn't it? But what happens if that something already exists? There's a directory there now called clean. Is that going to screw with our heads? Is that going to screw with make? I don't know. Let's see. And if we do an ls, those bloody dat files are still there. God. That's a bugger, isn't it, eh? How annoying is that? We've got a problem. Okay, so what we thought was a relatively simple rule and a relatively easy rule, that we could create a clean event to clean up after us, we have got something in that directory, or in the path that it searches through, called whatever that build event is. It's going to check it, you'll see it's there, it's not going to run the event. So, there's got to be a workaround. Of course there's a workaround. So let's have a look at the make file of it. So there's our clean events. We need to tell make specifically that clean is what we call a phony target. It doesn't actually create something, it just does something. Yeah? So we say,
now we're getting to make, I think.
that clean, and we've not actually done anything yet. So this is where people's eyes glaze over with make, and they just think, this is just not right. So we say that clean doesn't create anything, it's a phony target. Yeah?
What does phony mean anything?
Phony means it doesn't do anything. Phony is false. It's a false target.
Okay.
So we still want make to run the clean target. But because clean doesn't create something called clean, we don't want it to check to see something called clean exists. So we mark it as what we call a phony or a false target. So it doesn't actually produce something called a target name. It just responds to a make command for that target name. Yeah?
Can this stand anywhere in the make script?
Say that again, sorry?
Can this stand anywhere in the make script, or do we have it to write this phony directly before this?
No, it should work anywhere within the script. Okay. Honestly, I always put the phony targets with the targets, so I can remember that I'm marking this one as a target. So just good practice, really. You can put it anywhere, it should work anywhere, because all you're doing is marking the target. You can put them all at the top, but I tend to put them with the target I'm talking about, and I put my phonies at the bottom. So I know that I've always put my phony targets at the bottom of the main file. That's where they live. And that tends to be what people do if you look at people's main files. It tends to put the phonies down at the bottom. So we've got a phony target called clean. It's not going to build something called clean, but it's going to respond to a make clean command. So, we can, if you recall, just going back to the ILS.dat and abyss.dat rules, they're individual rules. And actually, if I've got 50 similar builds I needed to do, I'm not going to save myself any time at all, really.
It doesn't work if I say make clean with that phony target file. It says make nothing to be done for clean.
We'll come back to that in a minute. I've not quite finished this yet. Okay, so I've got more to do. Got more to do. Give me a minute. So, what was I saying? Yes. So we wouldn't save ourselves any time doing it this way, because then after type make a bis.dat, make ours.dat. So we do need to get to the point where we're automating multiple processes rather than just making more work for ourselves, which is essentially what we've done so far. So we've only got part of the way there. So what I would like to do is to get us sort of part of the way there, is to add an additional command that's going to create all of the data files together. So I'm going to create an additional phone target called DATS. And what DATS is going to do, what DATS is going to do, is it's going to build so what we've got here is we've got a rule and a target, DATS, but its dependencies are the targets of other rules, aren't they?
But then, yeah, you have to call them point that.
So that's a target of their dependencies, but the dependencies themselves are... Oh, sorry. Thank you, well spotted.
So it's as...
Yeah, so it's got DATS, yeah, you're right,
okay.
sorry.
Okay.
Do apologise. Yes, that makes sense, doesn't it? Of course it does. I'm building a DAT file.
Okay.
So yeah, those. So that's my target, they're my dependencies. But those dependencies are targets from up there. So it reads that, builds those, but for those, it goes and runs those rules to produce those dependencies. Happy with that?
Yeah.
Right. So far. So let's do that. Let's do it clear again. Let's see what we've got. So we've got some DATs in there. So I'm just going to, I'll do it manually. I'm going to take the DATs out. Right. So make DATs should run that new rule, that phony rule that runs other rules. Make DATs again should give us that output, because it checks to see what should be built, whether it has been built, it has, so it doesn't run the rule again. So, make clean runs my star.dat, which it should have, now mine ran, yours didn't, did it? Even though that clean directory exists, because it doesn't have a dependency and I created a failure rule.
But now it works.
Now it works. Murphy's Law.
Come on.
So that's what we've got to make file now. Right, something for you to have a go at. This is just material out of one of the software carpentry lessons. So what I would like you to do, at the bottom of the automation and make lesson 2, which I'll put a link to, just on the so right at the very bottom of this, I'll put the link on the EPUB. There's a little thing to try. It's about adding some additional rules. So a new rule for last.dat, and update the DATS rule, and and a new rule for analysis.tar.gzip, which you should find in one of the directories that you download. Let's give it a go. So I'm just going to put that link at the bottom of the pad. So exercise 1, so it's the last. So it's at the bottom of that. So give that a go. So it's an additional rule or two, and we'll see where we get to. I think the first one's quite straightforward. The second one might not be so. As you're doing that, I'm grudgingly put all my things together. Now, just another little request for feedback, and I think something that Martin will probably find useful, is right at the bottom, right at the very bottom of the pack. I've just put a little link that asks you to say one positive thing you've got out of today or that you plan to implement as a consequence of the workshop, and one thing that you would either like more of or would like to see improved. So one or two comments, please, just at the bottom of the pack before the day finishes. You don't have to do it now, but you could just do that. I think Martin will find that useful. So we've kept all of your little comments. We're going to give those to Sven. Sven can give them to Martin. And then, if you've got anything you want to pass back, then, so can you make sure Martin gets those? Yeah, thank you. Are you okay? So if you click, so, oh yes, yes, right at the very bottom. You're a big Make fan, Gregory.
I'm not here right now.
Not if I could help it, he says.
No, I haven't actually needed something like that yet. We have this horrifically huge configured make call for our system, which I don't have to touch. That's just a good enough.
It's always better when that's the case, isn't it? Absolutely. I don't think we get any extra coffee this afternoon, so if anybody wants to get themselves a cup of warm stewed coffee, then please feel free to do so. There's still plenty of water and juice left. And I'll have a few minutes, and then we'll see what we've got, and we can just look at 1 or 2 little pointers, and then we'll finish by about 3:15. Yeah. That's about right.
So,
As Edwin just said, the application that he uses has a configure file. Now, configure files are used to build make files. It is not uncommon for established research codes, for some reason, particularly weather modelling codes, don't ask me why that's the case, for configure files and make files to be hundreds, if not thousands of lines long. It might well be that a lot of the content's redundant, but because the code has been in development for many years, it contains targets for systems that don't exist anymore. That's not uncommon in well-established research codes. There's a standing joke about the UK Met Office research code, the UN Unified Model, that there isn't a single person left alive that knows how all of it works. And you can almost imagine that's the case with big weather modelling codes, because they've had so many hundreds, if not thousands of people develop them over the years, that people just end up adding tiny bits onto what already works. I don't know whether that's good or bad, it just is. So it does mean that when you see those really long configure files or really long make files, that they're very daunting. They can be terrifying to try and do something with. All you really need to do is maybe just add one extra rule.
What's a configure file?
So a configure file, so there's a set of build, we call them build tools, okay? Make is used as part of a family that we call the GNU auto tools, yeah? So a very common software installation process is to type in /configure, make, and then make install. So that's often the instructions that come with a piece of code. So configure, or configure.py, might be, is a file that maybe examines the hardware of your system, checks to see whether libraries and other dependencies exist in your various paths and LB library paths, and creates automatically a make file for your computer. So we might write a make file that requires a LAPACK library in one to be in a certain directory, that requires a fast Fourier transform library to be in a certain directory. It requires it to be in a particular release, a particular version number. Now, I can't guarantee that whoever I give my software to is going to have exactly those libraries installed in exactly the right place. So what we can do is to create a configure file that checks to see whether the dependencies exist and creates a bespoke, specific make file for that person and their architecture. So that's why we do a configure first. So configure checks the configuration of the system, builds a make file, and then runs the make.
Is that configure file basically bash script?
It can be a bash script, it can be a Python script.
Okay, but
That's essentially what it is, it's a program.
Okay, but there's no particular language like make that does configure.
No. There isn't a configured format, it's just a program. And it could be a bash script or a Python script, or even a Perl script. But it basically loads of if statements straight off.
Yeah.
And it will create as its output text file or make file with all of these build events created in it that should run for your system. You still don't like it, do you?
No, I came across this build routine.
it's horrible.
Yeah.
Sometimes it works, and then I think I feel like a great hacker. But
Other
But
times.
listening to this stuff, I think, who writes this configure file, or who writes this make? Yeah. Okay, configure writes make file, but writing this configure file. Just, no.
So because the configure file or the configure script is the more complicated bit. Increasingly these days, people don't write make files from scratch. They have a system that will automatically create that. Sorry?
That's that one thing. Automate.
Yeah, all of those things. Yeah, there are loads of tools that will automatically create a make.
There are also tools like make dependence, right?
Yeah.
This is one that's not working for me, although I think it's really a cool thing, but I mean, it doesn't help if it's not working.
No, and part of the reason so many of these families of tools exist is because writing a good makefile is really hard to do.
Yeah.
So people develop tools to create makefiles. And that's the way it is. Okay, so shall we have are people ready? You want to? Sorry.
And when do I actually use Makefiles? I mean, if I want to share my code, especially then, or is it also...
Okay, so traditionally we would write makefile and use make if we were distributing software. And traditionally compile software, so stuff written in Fortran or C. That's the traditional way of using makefile. Increasingly people use it to automate workflows. They are very good tools for automating workflows. So if you've got lots of data analysis, you need to run the same scripts on the same data on a day in, day out basis. Using make to do it is a really good way.
I came across this song.
Sorry.
Look how rarely they lock it and can all scripts together. So they have like their paper and they put the main file where they have dependencies of all their figures and all their tables in there.
Yeah.
And everything changes something with that. They run make, or they run make to compile the text. And then checks whether figures are up to date or not.
That's a really neat example.
Yeah.
I know someone who wrote his PhD's make.